Okay, trigonometry, brand new concept. What is trigonometry? Trigonometry is the study of angle angle measurements. So in other words, we're going to use some really strange languages like sine, cosine, and tangent. Those are called trigonometry. We're going to use those language to see what we can do to measure the angles. Okay? So here are some definitions. Sine of an angle. This is all of these three concepts, sine, cosine, tangent, are sine of an angle is the ratio of the opposite of the leg opposite the angle to the hypotenuse. In other words, sine of A is the opposite leg. Sine of A is here. Sine of A is the opposite leg, which is A, over the hypotenuse, C. Sine of B, which is this angle, the opposite of leg of that is the small b over C, the hypotenuse. The cosine is the ratio of the leg adjacent. So for A, the adjacent leg is B over hypotenuse. And then for cosine B, the adjacent leg is A over the hypotenuse. So cosine is adjacent leg over hypotenuse. And this is opposite leg. Notice we have two legs. One is called opposite leg. One is called adjacent. Again, opposite or adjacent, meaning opposite of the angle. In this case is angle A. In this case is angle A. Adjacent to the adjacent leg of angle A. Okay? And when we say sine B, it's opposite of the angle B. Tangent is the ratio of the leg opposite of the angle. So it's opposite leg to the leg adjacent to the angle. So tangent A would be opposite leg is A, adjacent leg is B. Opposite leg is A, adjacent leg is B. And tangent B, opposite leg is here. B, adjacent leg is A. Now notice that sine of one angle is the cosine of the other angle. And sine of B is cosine of, I'm sorry, right, so sine of B would be cosine of the other angle, right? Cosine of A. Whereas tangent of one angle is the reciprocal of the other angle. So those are just definitions. There is a quick and easy way to remember this. It's called, this is really, really helpful. You're going to hear me talking about it all the time. It's called Sohcahtoa. I know it sounds funny, Sohcahtoa. And you're going to hear math teachers, especially pre-calc teachers, talk about it all the time. And you're going to be like, what is Sohcahtoa? Now you know what Sohcahtoa is. Sohcahtoa means sine. Again, here, S-I-N is not sin. It may be a sin, but really it's the shortcut for sine. Sine of an angle, the S stands for sine, is opposite leg over hypotenuse. Cosine of an angle, the C stands for cosine of an angle, is adjacent leg over hypotenuse. Toa, meaning T is tangent. Tangent is opposite leg over adjacent leg. Okay? If you don't know what adjacent means next to, meaning the leg next to the angle. Also notice, I want you to notice that when we say sine of an angle, cosine of an angle, tan of an angle, we are talking about angles. So all the greens here are angles, are a big letter A, B, C. Whereas on the right hand side, we are talking about the length of the sides, right? So these are side length. So in other words, trigonometry ratios allows you to use side length to figure out the ratio of an angle. And we're going to see how that's used in our practices to help us. So let's look at it here. Here's some basic concepts. I have a right triangle ABC. Remember, it always happens in the right triangle. I've got 3 sides, so I can calculate my trigonometry ratios. Sine of A, sine is so, right? So sine A should be opposite over hypotenuse. Sine A is here, opposite is 5, hypotenuse is 13. Done. Cosine A, cosine is ka, so cosine is adjacent, which is adjacent to A. Adjacent to angle A is 12, the adjacent leg, over hypotenuse is 13. Tangent is toa, so I should have opposite. Again, we're still talking about A, right? So opposite is 5, and adjacent leg is 12. Now we said sine of one angle is the cosine of the other angle, so I can just simply copy it down here. We said cosine of one angle is the sine of the other angle. And for tangent of one angle is the reciprocal of the other angle. That's it. I found my 6 trigonometry ratios, or in other words, 3 trigonometry ratios for each angle. Now let's see. Here, this one I have a right triangle. I have 2 legs. I don't have the hypotenuse, but obviously I can solve for the hypotenuse. There are simple ways of solving it. If you notice that this is a Pythagorean triple, 3 times 3, 3 times 4. So this should be 3, 4, 5, which is my favorite, laziest Pythagorean triple. So this side should be 3.5, and that should equal 15. Now again, sine, sine is opposite over hypotenuse. Sine of W is here. Opposite is 12, hypotenuse is 15. Cosine is ka, so it's adjacent over hypotenuse. Again, I'm looking at cosine of W. Adjacent is 9 over hypotenuse. Tan is opposite over adjacent leg, so it's 12 over 9. Now notice these are not simplified, so you have to simplify them, divided by 3, so you should have 4 over 5. This one you should have 3 over 5, and this one you should have 4 over 3. Okay, now if you want to use our shortcut to find your sine and cosine of the other angle, that's fine. But this time I'm going to use the same approach, Sohcahtoa. So is opposite of x. Opposite of x is 9 over hypotenuse is 15. Cosine is adjacent. Adjacent is 12. Adjacent of my angle x is 12 over hypotenuse. That's 12. That's 15. And the tangent of x is opposite over, did I do that? Yeah, it's the opposite over adjacent, right? So if you simplify this, you would have 3/5, 4/5, and then this would be divided by 3, 3/4. Now notice these two matches, these two are reciprocal. So we've definitely accomplished that. Same thing here. You can do this by the exact same method. So do that one on your own. If you have a calculator in your hand, so you should have that ready with you. for this part, I'm going to try to demonstrate to you how we use a calculator to help us with this. So you already learned how to use Sohcahtoa to find side length especially. So let's try this. I've got 19 on the hypotenuse. I've got 28 degrees. I've got the opposite leg. So obviously, if I have opposite over hypotenuse, that would be so, right? Which is sine. So if I plug it in, I would have sine 28 degrees equals opposite, which is x, opposite leg, over hypotenuse, which is 19. If I simplify it, I would have 19 times sine 28 degrees. Now you can use your iPhone. If you use your iPhone, the way to calculate sine of 28 degrees is to plug in 29 and then click on sine. So you should have about 0.47. And then you bring the 19 down. If you're using a calculator, you can just find the button that says SIN, that's sine, and then plug in 28. That's much easier. But for iPhones, by the way, for iPhones, you have to hold it sideways so that you can see the sign, and then plug in the 28 first, sine, and then so therefore multiplied by 19, your x is approximately 8.9. That's your final answer there. Okay, so just to recap, what we did was we used the definition of trigonometry. In this case, it's sine, because I know that opposite is given, hypotenuse is given, and then I can use the definition of sine to solve for the side length. And I just borrowed my calculator for it. So let's look at another example. Let's look at number, which one is easier? Let's look at number 4 maybe. So in this case, the angle is here. I have the opposite. I have opposite leg. I have the adjacent leg. Hypotenuse is not involved. Opposite and adjacent legs, that's tan. That's TOA, right? Tan equals opposite leg divided by adjacent leg. It has nothing to do with hypotenuse. So tan 55 would equal opposite is x, adjacent is 8. So when you do tan 55, you can multiply, you can do tan 55, that's about 1.43. So if you multiply tan 55 on, if you multiply both sides by 8, you should have x. So your final answer is x equals 11.43. That's your final answer there. Okay? Let's see. Let's look at a real-world application problem here. It says Jake leaned a 12-foot ladder against his house. So if you have a if you have a house here, I don't know, it's some windows, maybe this is your bedroom, right? And then this is the door. This is your beautiful house, maybe with a nice patch of grass on the outside. Now, I did not do a great job because apparently your house is not straight in this case. But now I'm gonna lean my ladder here. Okay? And then it's asking me, let's see, what does it say? It says that if my ladder is here, I'm leaning this ladder here, and this ladder is 12 feet tall. And if the angle formed by the ladder and the ground is 68, ground is here, ladder is here. So it's this angle is 68 degrees. How far from the base of the house did he place the ladder? So in other words, what's the distance from the base of the house to the beginning of the ladder? How far is x? So let's see. I have an angle here. The adjacent leg is given. The hypotenuse is given. So adjacent divided by hypotenuse, that should be, that's not so, that's ka, right? Sohcahtoa. So ka is, so cosine of 68 degrees should equal to adjacent, which is x, divided by 12. And if you use your calculator, you do cosine 68, that should be 0.37 multiplied by 12, that, oops, sorry about that. That should be x equals 4.5 feet. So in other words, in this case, the x is 4.5 feet away from the house. The ladder is 4.5 feet away from the house. So with this kind of practical problems, draw a triangle or draw a diagram that represents the problem, and then use your knowledge, convert this type of problem into the more abstract ones. Believe it or not, the more abstract ones are easier to solve. Okay? I will probably go through some of these homework problems during class. Let's see. Yeah, some of the more complex ones, like 12 and 13, we'll probably go through it in class. Give it a try yourself. And the trick is, if you are asked to find this part, if I call DCX, you have to use this small triangle, find y first. That way you have two legs, right? And in here, I'm asked to find KL, which is x, and I only have an angle here. I need to either know this hypotenuse or need to know this leg. It's much easier to know this hypotenuse. If I call this y, obviously you can use this this 51 degree angle to find the relationship between y and the two legs, y and 14. Okay, so I will see you in class, guys. Bye bye.